everybody, today I want to show you a Desmos graph I made. It involves coterminal angles and is really powered by mods. So what I was looking to do was find a way in class to be able to show that as I go around and around a circle that my angle really starts over again. So that big angles like 760 have an equivalent angle less than 360, and in this case it says it's equal to 40. But I know I'm not a great drawer, so I knew that if I tried to draw this on the whiteboard, it wasn't going to look good, but if I went to Desmos, I could get a really pretty graph. So the two things you're seeing right here, the first one, D, is the number of degrees of the angle showing. So as I go round and round and I go to different angles, I can keep track of my really big angle, but then the A shows me the coterminal angle that's between 0 and 360. Let's go something small like 370. You can think 370 minus 360 is 10, so I have this coterminal degree of 10. Let's say I go to about 400, and again we can think 400 minus 360 gives me 40. So it's kind of easy to just subtract when I have these small numbers. But as I go around one more time, which takes me to 720, you can see I'm back to 0. So now as I get bigger, I'm not subtracting 360, I'm subtracting 720. So we're taking away this multiple of 360. As the numbers get bigger, we have to think a little harder, but this interactive kind of does it for us, which is really nice. Now right now I have this set to go from 0 to 1440. If I wanted to change the settings and show that this also works for negative, and start again at 0. So when I look at negative values, this gives me the equivalent positive angle. Here at negative 260, I can see I'm over in quadrant 2, and it says that's the same as 100 degrees. What happened? Negative 260 plus a positive 360 gives me a positive 100. Mods are always going to be positive, which makes mods a really good operation to use when I'm trying to do coterminal angles. A little bit of the hidden magic behind this graph is this untitled folder. The first thing I had to put here was a circle. So I put a unit circle, x squared plus y squared is equal to 1. Then I wanted this line to represent the angle that I'm looking at. So we know when I graph a line, I kind of need two things. I need the slope and I need the y-intercept. Luckily, the y-intercept is the origin, so I have the point 0, 0, which tells me all I really need is the slope. The slope here is the y over the x. Well, y is going to be the sine of the angle, x is going to be the cosine of the angle, sine over cosine is going to be tangent. So I just need the tangent of the angle. The angle I want to use to keep things easy is the A at the beginning. So here you can see I have y equals tangent of A times x. So I used y equals mx plus b. The b is 0, so I have y equals tan A. I do have this written twice. Watch, there's a top part and there's a bottom part, and I have them in two different colors so you can see that there's two different lines. The reason I have two different lines is this. If I type y equals, in parentheses, the tangent of A times x, I get a line. And what I want is a line segment. I want to go from the center to a point on the line. So I separated that into when y is positive and y is negative. So I said for the positive values of y, which will be positive angle, then I also want to have a positive y. So I put in that y is greater than 0 and is less than sine of A. And notice it turned into a line segment. Then for the second part of the graph, where my angle is greater than 180, y will be negative. So I put in a y is equal to the tangent of A times x, and then I had to tell it that A is greater than 180. Then to keep y below the x-axis, I have sine of A is less than y, which is less than 0. Then I hid all of these functions inside the folder and closed it up. Now I have this nice little graph that goes round and round, and I can show equivalent angles in class. You can find the link to this graph in the description of the video.